Hello everyone, welcome back. Here is vanAmsen, and today we are diving deep into a fascinating LeetCode daily challenge problem: minimum operation to reduce x to 0. And guess what? We are doing it in Rust. So let's get coding. And the problem is simple but quite tricky. So we got an array and a number x, and we can remove elements from either side of the array and subtract them from x. And we need to minimize the number of operations to reduce x to 0. And if it's possible, we return -1. So let's spice things up by solving this in Rust. So last time we solved it in Python, but also we'll compare it with performance of Rust. So before we jump into the code, let's go through some logic. So and example as well. So if we have array as follows, so 1, 1, 4, 2, 3, and x equal 5. So how to make it 0? By subtracting 3 and also 2. And yeah, so basically if we subtract 3 and 2, it's getting 0. And how many operations we need? 2. So our output should be 2 because we use 2 operations. Okay, so now as we understand also the example, and the intuition approach may be to find the minimum number of elements to remove. But we are going to flip this problem. So we will look for the maximum subarray we can keep. Yeah, so all right, let's get our hands into Rust. So for those who are not familiar with Rust, don't worry, I will also provide implementation in other languages. So first thing first, let's let mutable target i32 as minus x, and n will be num length as i32, and for num in nums target plus our num, yeah, type of num. Okay, so if target equal 0, return n. And let mutable max len current sum mutable and left 0, 0, 0. So what we are doing, so we start by calculating the target, which is sum of array minus x. And if the target is 0, it means we need to remove all elements, so we just return the length of the array. And we initialize also max length current sum and left to 0, and this will help us to find maximum subarray. So now let's dive into core logic. So for write in 0 to n as unsize current sum plus num right, and while left less than right as i32, current sum greater than target, current sum minus num left as usize and left plus 1. And if current sum equal our target, max length will be compare max length and right as i32 minus left plus 1. So rolling window, and if max len not 0 and minus max len, and else it will be -1. So this is our return statement in Rust. So and there we have it, sliding window approach, yeah, quite nicely implemented. And we traverse the array with right pointer, adjusting our left pointer whenever the current sum exceeds the target. So simply logic. And if we find a subarray with a sum equal to the target, we update our max length as for formula. So let's also run it for this test case to verify it's working. So hopefully it will. Yeah, so all good. So there we have it. And now last part, submit it for unseen test cases to double verify. So it took, 90 milliseconds, beating 40% with respect to runtime and also 40% with respect to memory. So also we can rerun it to verify it's working. So as you can see now it's 15 milliseconds. I don't know what was my best, but probably around these times. So beat 60% and also 60% with respect to memory. But it's just 50 milliseconds and 2.9 megabytes. And if we compare it, for example, to previous solution in Python, same logic. So Python got 932 milliseconds and also 30 megabytes of memory. So as you can see, it's 50 times more efficient, 10 times more efficient with respect to memory. And also, really, I don't know why, but quite significantly, basically, Rust is really efficient language, and it's sometimes even outperform other languages like C++. So I hope you like this implementation, and if this session make you understand sliding window technique better, hit the like button, and let me know in the comments what next task you would like me to cover, and check the video description for other implementation as well, and subscribe for more coding challenges, tutorial, and much more, and also keep practicing, and happy learning.